In a previous video, we discussed the importance of using the hands-on approach when teaching chemistry and chemical reactions. In this video, we'll expand on how different learning styles can be used when teaching chemistry. The outcomes of this video are to show different teaching techniques used for group work in the classroom, to use OBE type of activities to explain difficult chemistry concepts, to show how the different learning styles of learners can be accommodated. At Rockland Senior Secondary, the teacher, Mr. Adil Adams, is preparing his class for a lesson on the different phases of matter.
Air is made up of particles. That is the statement I'm going to make to you.
In the first activity, the teacher presents the learners with a questionnaire containing the statement, air is made up of particles. They are required to discuss this in their groups and answer 3 questions. The questions are, do you agree with this statement and why? Why is it not possible to see the particles? And what kind of particles do we find in air?
There are particles in the air, it's just that it's minute, we can't see it. What type of particles do we find in air?
We find dust in air because they are very small particles.
The main outcome would be obviously the interaction in the groups, understanding of the theoretical part of the structure of matter.
During this activity, the teacher will facilitate the lesson by moving around the class, listening to the different groups. In this way, he'll get an idea of the learners' preconceived ideas on the subject.
Learners are exposed to science in their everyday life, and they develop concepts which help them to answer the issues and the questions which face them. And those everyday understandings of science are not always completely valid in terms of scientific knowledge. And it's really hard to shift somebody's understanding when it's been ingrained since childhood. So teachers really need to work very hard to break the old picture and replace that with a new, properly scientific concept.
Let's get some feedback on the answers now. For the first question, let's see.
I say yes because air is matter and matter is made up of particles.
Excellent. Air is matter, and you said made up of particles.
We say no because we can't see it.
Why is it not possible to see the particles?
The particles are minute and transparent and you cannot see them with the naked eye. And odorless.
It's tiny and it's colorless.
The teacher writes the points on the board, even though some of them are incorrect.
That's where this becomes really important, because you don't want to devalue what the learners bring to the table, and at the same time the teacher needs to understand what the misconceptions are and then develop ways of dealing with them effectively.
The teacher will then indicate which answers are representative of the correct ideas.
Colorless. And another word I would suggest then is they are microscopic. Right? Then the third question then now, what kind of particles do we find in air? Something that we have to inhale, oxygen. Something we exhale, carbon dioxide. Right? And then there's nitrogen, and of course the little dust particles that's flying around. I'm going to do a demonstration for you, and you must now do 2 things for me. For the first one, you must use the skill of observation. Right? In these 2 bottles I have a solution of ammonia and a solution of hydrochloric acid. Observe. Do you notice something happening? Yes. Keep that in mind, okay? And bear in mind now, air is made up of particles, and that these particles are moving. Have you got it?
Demonstrations have a very important place to play in the general process of a lesson. The problem is that in the past they've been overused and used inappropriately, but in the right place at the right time they do have a use. And given the fact that many schools don't have sufficient resources to do something with the whole class at one time, it's very important when you do the demonstration to have the tables and chairs or desks laid out in such a way that the kids can actually get to see what's going on properly.
Demonstration 2 then will take place now. You must raise your hand as soon as what happens? Excellent. Are we ready? I think demonstration has a role to play because of the impact it has on the child, the immediate impact. The cloud they saw, the sort of white cloud they saw, it had an impact on them immediately. And then when I squirted the second one, and I squirted the air freshener, the smelling part, they reacted to it. And then I asked them to apply it in the little handout I gave them. Okay? Very important. You must do it 2 ways for me. First, you're going to do the table on your own. Secondly, you will do the table then in the group and discuss, and then I want feedback from your speaker.
The way in which the lessons were conducted was an attempt to give expression to the learners' different learning styles. First of all, the children did individual work. Then there was group work, and those are two very important intelligences. Some people are just better at working on their own than others, and others are better at working in groups. But we need to ensure that learners get a taste of both, because in life we work on our own and we always have to work in a group.
Yes. Size counts. There is space between air particles.
False.
False. Why do you say so?
The space depends on the space, I mean the phase that it's in.
Yeah.
Liquid, solid, and gas.
So there are spaces
Because
at times.
if it's
definitely
solid,
spaces.
if it's solid, the particles are closer. Liquid, it moves further apart, and when it's gas, it moves even further apart. So.
After discussions in their groups, the teacher consolidates the information.
Matter consists of particles. Do you agree with this statement as well? Matter consists of particles, true or false?
They consist of gas particles, liquid particles, and solid particles.
In other words, the various phases of matter. So we agree then, it's true then. All particles are too small to be seen by the naked eye, and here we need to be careful. Let's start with your group at the back inside.
True and false.
True and false. Okay, I'll make a tick there.
Gas you can't see and solid you can.
Let's look at the third one now. All particles are always moving at the same speed.
We'll go with false because the speed depends on the temperature.
Can you tell me why? Going back to the demonstration.
The higher the temperature, the faster it moves.
Excellent.
And the lower the temperature, the slower it moves.
Today it's a bit colder. So when I squirted the aerosol or the air freshener, it took a bit longer. So the temperature is a very important factor. It will determine then how fast that particular particle will be moving. You got it? Then let's look at the last one. There is space between air particles.
The space between the particles depends on the phase that it's in.
Yes, it depends on the phase that that particular particle is in, being gas, liquid, or solid.
After the report back, the teacher refers to the demonstrations to explain the findings of the learners on particles.
Do you notice something happening? When I kept them close by, what did we see?
Smoke came,
Yes, and
and it disappeared.
in actual fact, it's small, solid particles that after a while, it disappears. You got that?
The teacher explains to the learners that the solid particles are in fact ammonium chloride.
On the space, I mean.
Then let's look at the second demonstration now. Why could the people in front smell it first and the people at the back last?
We were closest to the aerosol cancer.
Putting it in a nutshell is, they were sitting in front, they got the whiff or the smell first as the aerosol traveled, and you got the smell last.
This could also be a class project where learners measure the time for diffusion to take place on a cold and warm day, keeping the parameters constant. For example, distance between the sprayer and smeller, height of can and amount of spray. In this activity, the teacher presents each group with 21 polystyrene balls in 3 different colors.
Yellow.
Each group is also presented with a chart divided into 3 columns, each column representing a container.
Each styrofoam ball represents a water molecule. I want you to make a microscopic representation of water in the different phases: gas, liquid, solid.
After the prescribed time, the charts are hung onto the wall. This gives the teacher a chance to see what the preconceived ideas of the learners are. Each learner is then given an information sheet on the subject.
Now you are free now to make any changes on your different structures based on what you've read. It's important that you have an idea where the child or the learner's knowledge is or of a particular idea. And then if it's wrong, I think that's where the learning comes in, when you rectify the incorrect perspective. And you concretize it with, especially this way, a visual impact, and it is actually working with it hands-on. It makes so much more sense. It has a lasting memory on it. They won't forget it.
When the learners have corrected their charts, the teacher will evaluate them and report back to the class.
Let's look at the phase gas. If I go around, I look at this one, it's correct. Remember, gas is spread out quite wide. In this case, as it is here, there's no structure, it's fine. Looking at the liquids.
The teacher goes on to show that the particles in liquids also do not have a pattern and that gravity would take them to the bottom of a container.
In each case, it will go lower down. In the case of the solid, there must be a pattern. And the pattern must be one at the bottom, one at the top. And it will not be here, it will be at the bottom.
The learners go back to the charts and make the changes. This is the slow process of constructivism.
Aha! It's time to dance. Yes, we're going to design a dance that will represent the different movements that particles have in different phases.
In this activity, learners are required to represent the movement of water molecules at different temperatures, ranging from -20 degrees Celsius to 130 degrees Celsius.
We're going to be amazing.
Different children learn in different ways. And some children have a very mathematical, logical way of thinking about things and learn in a very linear way, whereas other learners actually need to physically jump up and down in order to come to grips with what it is that they're trying to learn. And one of the reasons that we have fewer learners taking science than we should have in this country is that they see it as being this enormously academic subject that is beyond the pale of the average learner, and that's absolutely not true.
Ice at -20 degrees. Water at 15 degrees. Water at 75 degrees. Water vapor at 130 degrees. Water changing from a liquid to a solid.
We just need to recap on a
At the end of the lesson, it is important that the teacher summarizes the main points again. This focuses the learner's attention on what the lesson was about.
Air is made up of particles. They exist in different phases. Gas, liquid, solid. And very important, and in each phase, the movement varies. I would say if you have lessons where you have this very theoretical aspects to explain from a scientific point of view, I would say sit down and plan and look at different ways, more visual, more practical, more hands-on ways of showing things that the child cannot see, for example.
And on the studio with me, I have Lolo from Protec, I have Liz from WITS, and I have Abdul from WITS. We are going to reflect on the lesson that we have just observed. What we are going to talk about is the teaching strategies that the teacher has used on this lesson. He has used a variety of teaching strategies, starting from concentrating on an individual learner, to modeling, and up to an actual dance at the end. What sort of comments do you have about teaching strategies in this particular lesson?
Regarding the models, I mean, I think that was useful as well, but what I do also think is models and analogies that are used in order to explain theoretical concepts, it's useful. But one needs to sometimes emphasize that models and analogies have their limitations in a sense. And sometimes one needs to emphasize what these limitations are.
The point you're bringing in here is how do you link the hands-on to the minds-on? Because they are doing a hands-on approach by actually doing all those things. But how do they link that with the actual on their minds? Does the whole concept link to what they are doing in the classroom? And I think it's important for the teachers to, whatever practical work that is done in the classroom, to link it with the actual theory or concept.
Especially in chemistry, it's important to see the concrete, the reactions taking place, the experiments. But chemistry also has the symbolic, so one needs to write equations and its formulae. But as well as that, unless one makes models or the dance of the particles, one misses out on that idea. And I think that's how learners develop their mental ideas about chemistry.
And one of the things that the teacher did on the video was actually to give, like you have said, to give the learners some balls in order to show a model of the phases and particles. Now, in this lesson, for instance, we're talking about the movement, we're talking about substances, we're talking about particles. Do you think the teacher was in a position to differentiate for the learners on those key ideas? What's your view about that?
Well, I think the teacher handled things very well because he first asked the learners what their ideas were. And I think that's a sort of key principle in teaching. Start with what they already know. And he was able to select the things that were right, about what learners had said, and to develop their understanding a little further from when they started. So I think that was really excellent, the way he used the models. And the way he used the flip chart as well and picked up ideas from their report back.
Yes, he didn't just discard the previous relevant knowledge in a sense. He used that in a meaningful way to expand their ideas and extend their ideas in terms of what Liz is saying here. So, you know, sometimes what happens is we just tend to think everything, or students' ideas, they have misconceptions. Sometimes one needs to think that they come to a classroom with rich conceptions, and one needs to take those conceptions and then and expand on them so that they become scientifically correct conceptions in a way.
How do you handle a case where a teacher himself does have misconceptions?
Can I share this with you? I was in a class observing a teacher, and the topic was HIV/AIDS. And he was telling the learners that there's a cure for HIV/AIDS. And then this learner stood up and said, no, we don't. But there's something that is being given to the baby that helps the baby not to contract. But there is no cure for those who have HIV/AIDS. And the way the teacher handled that, he did not admit openly to the learners that he was not sure. Then he said, let us go and find out really that the statement is true.
I think that was a good idea. That's a good idea. And one of the things that we observed on the video was when the learners were actually giving some report back on the task that was given to the teacher. And how did you find them, the learners, how did they respond to the task that was given by their teacher by actually reporting or giving feedback on what they were doing?
I think the opportunity for them to talk about the concepts in groups was good, and the opportunity for one person to represent the ideas of the group in the report back. I think those are very valuable learning tools.
Working in groups helps learners to involve all the facts needed in a topic because they always share. So for them, when they go out and report back, they almost have all the necessary information needed for the topic.
And for me, the report back that was done on the video actually helped the teacher to emphasize the point that he wanted to reach as in the form of the outcomes that he had actually set for himself for the lesson. So as the different groups were reporting, then he was able to tick out all the outcomes that he had set for his own lesson. Is there anything on the overall that you liked about this lesson?
I think there were lots of things that I liked. It's so easy for teachers to fall back to the chalk and talk method, where they just stand at the board and talk. And so this was really great to see so much interaction and variety.
It shows really that they are moving from the teacher-centered method to the learner-centered one, because learners were engaged from the beginning until the end of the lesson.
And I also like the end part, towards the end, where learners were actually demonstrating by actually showing the different phases. And for me, that was a very good teaching strategy. I think that is all we have for today. And thank you very much for your contributions. Lolo, thanks Liz, and thanks Abdul. Thanks to all the viewers. We'll see you next time.